To start, we'll be creating the EC2 instance to deploy our web application on. So go to the AWS Management Console and search for the EC2 service. Here, launch an instance by clicking on the Launch Instance button. For the AMI, select the Amazon Linux 2 AMI. Leave this as the default option. Change the auto-assign public IP option to enable. Leave this as default. For the tags, we will add a tag. The key will be name, and the value will be ESDE web server. For the security group, we will create a new security group of web security called web security group. Now we will press the review and launch button, and here once you have verified that all the information is correct, we will launch the EC2 instance. So here we will need to create a new key pair. So select create a new key pair, leave the key pair type as RSA, and name the key pair as ESDE key pair, and download the key pair. So once that has been downloaded, we can launch instance. As you can see, our EC2 instance has now been created and is running. Now I'll be creating an elastic IP address. So in the site nav bar, we'll go to Network and Security and select Elastic IPs. Here, click on the Allocate Elastic IP Address button. Leaving the settings here as default, scroll down to the bottom and click on Add a New Tag. The key will be name, and the value will be Elastic IP for ESDE web server. Once you're done, you can click the Allocate button. As you can see, our Elastic IP address has now been created. Now I'll need to associate this newly created Elastic IP address with my previously created EC2 instance. To do this, I'll select the Elastic IP address and select under Actions, I'll select the Associate Elastic IP Address option. Here I'll select the EC2 instance that I had previously created and click the Associate button. Our Elastic IP address has now been associated successfully with our EC2 instance. To log into my EC2 instance, I'll be using WinSCP. So I'll start a new session, go to new site, and for my file protocol, set it as SCP, my hostname as my Elastic IP address, username as EC2 user, port number as 22, and now I'll go to the advanced settings. Under SSH, go to authentication and look for my private key. And select it and press OK, and now log in. As you can see, I've now been able to log into my EC2 instance and I'm able to access the file directory of my EC2 instance. Now we will be installing Node.js on our EC2 instance. To do this, we'll have to press Ctrl P to access the EC2 instance terminal, and then copy and paste the following commands that you can see on my screen here into the terminal. Next, we'll be deploying the bdesign app onto our EC2 instance. To do this, we'll need to modify some of the source codes on Visual Studio Code. So I'll go to Edit, Replace in Files, and replace localhost with our Elastic IP address. Next, I'll go to the index.js file and remove hostname. Now I'll be creating a new directory in the EC2 instance. And moving the source codes of the application into the EC2 instance. Now we'll be installing the node modules for the bdesign application into the EC2 instance. We can do this by running the npm install command into both the backend and frontend folders of the project. Now that the source codes of the bdesign application have been uploaded, I'll need to change some of the security settings of the EC2 instance to allow for the application to run properly. To do this, I'll select my EC2 instance, go to the security tab, click on the security groups, and here I'll edit the inbound rules. And I'll add the following rules. One custom TCP type rule for the port range of 5000 and one more for 3001, and set the source as anywhere IPv4, and I'll save rules. To create the database, we will choose a standard create method. For the engine, we'll select MySQL. We'll leave the version of MySQL as the default version, and we'll select the free tier template. Under settings, we will name our database under the database instance identifier, and as for the credentials, we'll create a master username of admin, and I have set my own password here. We'll leave the rest of the settings as the default, and we will create a database. To allow access to the RDS database, we'll need to configure some security settings. So we will select the RDS database, and we'll go to its security groups, go to inbound rules and edit inbound rules, and create the following rule, a MySQL type rule, which covers the port range of 3306, uses the TCP protocol, and the source is anywhere IPv4, and save rules. Next, we will also need to take note of this RDS endpoint, as we will need to use this to connect to the RDS using MySQL. To connect to the RDS database, I'll have to click the plus icon in MySQL here and open up my new connections tab. And here I'll fill in some information such as the connection name, which in this case I've decided to name as ESDE web server, the host name being the endpoint of the RDS database, and my username and password, which I set when creating the RDS database. And now I'll click test connection. As you can see, our test connection has been successful. If the connection testing has been successful, you may now click OK. Now I'll run the SQL script with the structure of the database. To allow the code to use the RDS database, I'll go to the database.js file in the config folder, and I'll replace the host with the endpoint of the AWS RDS. Now I'll log on to the EC2 instance using WinSCP and replace the backend folder in the EC2 instance with the new one that connects to the RDS. Now I'll reinstall the node modules in the backend folder. Now that the node modules have been installed, I'll be running the seed-data.js file. Now that the seed-data.js file has been run, our database has been populated. To move the database from MySQL to DynamoDB, we will need to export some of the database tables to DynamoDB. To do this, I will go to File, the File table, and select Table Data Export Wizard. And now that everything's been selected, I'll go to Next, select JSON, and select a folder, and select Next. Now we'll be creating the DynamoDB database by going to the DynamoDB dashboard and selecting Create Table. Now we will be naming our table. So in this case, I've decided to name my table as Files, and we will be typing in the partition key. In this case, it will be file ID, and it will be a number, and we'll create table. Now that our DynamoDB database has been created, we will need to create an environment in Cloud9. Now I'll be installing the AWS SDK. And now we can run our seed files table.js file. This will allow us to populate the DynamoDB database with the JSON file data. As you can see, we have finished seeding the database. Now to use AWS Lambda, I'll be creating a function by selecting the Create Function button. Here we can name our function. In this case, I've named my function as getDesign, and we can, as for the runtime, we can leave it as node.js. We'll need to change the default execution role and use an existing role. In this case, we'll be using the let role, and we will create function. Now I'll be reopening my Cloud9 IDE, and I'll be inserting the dynamodb.js file and the index.js file provided. I'll be using the following command in the terminal to create a zip file containing dynamodb.js and index.js. Now I'll be running another command to send the following code in the files to the Lambda function. To create the API, I'll go to the API Gateway console, and I will select Create API. Go to REST API, not the private one, and select Build. Here I'll select the protocol as REST, and for the Create New API method, I'll select New API. As for the settings, I'll just put the API name. In this case, it's bdesign API, and I'll create API. Now I'll be trying to create and configure the getDesign method. To do this, I will select Actions, Create Method, and select the Get method and save it. Now I will select integration type as Lambda function. I will check the Use Lambda proxy integration. As for the Lambda function, I will search for the getDesign Lambda function, and I'll save. To set the URL query string parameters, I'll go to the method request, go to the URL query string parameters, and add a query string of FID, and save it. For the next step, I'll need to copy the RN of the let row, which can be found here. Now I'll go to the integration request, and under execution row, I'll add the RN of the let row that I copied earlier, and save. To enable cross-origin resource sharing, I'll go to Actions, Enable Cross, select both the default 4xx and 5xx for the gateway response, and here I will add a user at the back and enable CORS and replace existing CORS headers. To deploy the API, I'll go to the Deploy API action, select deployment stage as new stage, and label the stage name as test, and deploy the API. Before I save my changes, I'll need to copy this, and I'll need this link to be able to invoke the API from API Gateway. So I will copy link address, and I'll save changes. Now I'll be modifying some of the source codes in the EC2 instance. So I'll have to go to the JS folder in the front end in the EC2 instance, select the update design.js file, and select edit to open up the editor. Here I'll be scrolling down to the get1data function, finding the URL here and changing it to the URL of the API gateway function. And now I'll be appending the FID here, so I'll put a question mark FID equals, and this will allow us to get the file ID and pass it to the rest of the code.